You'll see a very weird thing in C, and you should not use it unless under threat. Okay, so in C it can sometimes, but not very often, be worthwhile to use a goto. It can simplify the code, both for writing and for reading, but usually it should be avoided. And what we will see now is to jump from one function to another. This may sound completely horrible, but it's not as bad as you might think first. Namely, we cannot jump into a function, since that would be a very weird thing to do, since the stack has not been set up. What we can do is to return to a previously active function. That function is active in some sense, since it has a stack frame, and we can return to that. So, for example, say we call F, and F calls G, and G wants to return directly to F directly to main, without returning as normally done to F first, and then let F return to main. Okay, so we will see how this can be set up. And this point is very important to notice, namely that it has an even worse reputation than goto, and it's absolutely very, very rarely useful. There are occasions. One such is if you write a chess program and you have discovered winning sequence and you are running out of time. Then it may be very good to make the chess move as quickly as possible and skip all the searches. Okay, that may work, but it's in such rare occasions. Okay, so what is needed to jump back somewhere? If we want to jump back directly to main, then we need somewhere to resume execution. So a copy of all the registers and of the program counter, well, that's also a register, must be saved so that we can jump to that position. What we basically do is to save them in a variable. The type is jump buff, and what we can do is to read all the registers saved in this jump buff, and at last reading the program counter so that execution will resume at the address that was saved. Okay, so again, we cannot jump into an as yet not called function. We can only jump back to somewhere which has a stack frame. That's very important. Okay, and we need to initialize this jump buff variable. Well, that's the type and not the variable, but okay, and we do that with a function called setjmp. And then we do the jump with something called long jump. Okay. So note again, it's almost never needed to do this. And well, this is what I mentioned before about the chess program. And what is also very important is to know is that optimizing compilers really dislike functions which can jump away arbitrarily or be jumped to arbitrarily, because that prevents several optimization opportunities. Oops. Now we went too far. Okay, here we go. So, how is this done? Well, we can have a buffer, and this is just a variable. And what we do here in main, we set up this buffer using setjmp. This is not a normal function, but what it does is this is typically written in assembler, and it fills this buffer and returns 0. Okay, and using this switch, we set one case for 0. So this is, I mean, when we come to case 0, this is the initialization, and all other cases are from a long jump. Okay, so let's say, well, there is no call to G here, but let's say that there was a call to G from main somehow, and after this set jump, of course. Okay, so what we can do then, if we realize that we must return back here, we can do long jump with this variable and a parameter, and what will happen now is that execution looks as if it returned from the set jump without set jump being called. Okay, so this value 1 is the return value of the set jump, so we will go there and do something. Okay, I already mentioned that.